And welcome to part 3 of Taking the Regents with Segelke. Let's resume with number 37. What is the percent composition by mass of nitrogen in this particular compound? Recall, this is the formula we need to use from table T. I have identified the whole. The whole is the whole thing, which of course is this ammonium carbonate. The part, be careful, it's nitrogen. But don't forget there are two nitrogens. When we substitute in their gram formula masses, they were nice enough to tell us the gram formula mass of the whole, 96. And when I did 2 times 14, I got 28. And when we multiply that quotient by 100, we simply get an answer of 29.2, choice 2. 38, given the balanced reaction, which type of chemical reaction does this represent? Well, remember, whenever you have a compound reacting with an element, and that produces a new compound and a new element, that is always what we call single replacement reaction. 39, they would like you to identify the nonpolar molecule that contains polar covalent bonds. Well, let me remind you, to be a nonpolar molecule, oh snap, you have to be the symmetrical one. Which of these is symmetrical? Well, that's a symmetrical molecule, but that's a symmetrical molecule as well. So we can eliminate 3 and 4. Now, which of the 2 remaining molecules contain a polar covalent bond? Well, remember, if you're a nonpolar covalent bond, you have 2 of the same nonmetals. If you're a polar covalent bond, you have 2 different nonmetals. That means choice 2. Question 40. The graph shows the reaction is at equilibrium after 60 seconds because the concentrations of both NO2 and N2O4, well, it's the parallel lines here, guys. Equal rates, constant concentration. It's that simple. Number 41, which statement describes the changes in energy and bonding? Well, my friends, this is where we use BARF. Recall that to break a bond is to absorb energy, and releasing energy corresponds to forming of a bond. Notice here, you've taken a compound and broken it. Break, so that must mean absorb energy. Energy is absorbed as the bonds are broken, choice number 4. Our helpful part. Number 42, at standard pressure, what is the temperature at which a saturated solution of NH4Cl has a concentration of 60 grams in 100 grams of water? Well, my friends, we can only do this if we go to table G. So let's go there. Here's table G. Remember, table G is based upon 100 grams of water. It asks us to find 60 grams. We're going to follow 60 over to the NH4Cl line and then drop a line down to see what temperature that is. So I dropped the green line down. So it's, I don't know, 66, 67. Let's go back to the test. Yes, indeed. Question 42 is 66 degrees Celsius. Question 43, which aqueous solution has the highest boiling point at standard pressure? Well, let's remember one thing. As I sketched over here, any solution that you make in water, doesn't matter what it is, it's going to have a higher boiling point than pure water. This actually is one of the tougher questions. The first thing you have to realize is that more concentrated solutions are going to raise the boiling point more. So let's say that 1.0 molar would raise it that amount, and 2.0 would raise it that amount. So we can eliminate choices 1 and 2. Now, when you're given, this is the sloppy method, count up the number of atoms. The more atoms there are, the higher the boiling point's going to be. The stricter answer is that CaCl3 has 3 ions, whereas KCl only has 2 ions. So your answer has to be the more concentrated one with more ions, higher boiling point. Which change in number 44 causes the equilibrium to shift? Well, remember, there are 3 things that can cause equilibrium to shift. I can change the temperature or concentration. If I'm dealing with a gas, I can change pressure. There are no gases here, so let's get rid of pressure. Guys, catalysts, as we said, have absolutely no effect on equilibrium. A noble gas, this is weird. Why would they even add that one? That one can't be right. It's got to be increasing the temperature. And why? When I increase temperature, I put an up arrow by energy. An arrowhead touches an arrow tail, meaning the forward reaction is favored. But the question is even easier. They just need you to narrow down to temperature. Number 45, which hydrocarbon is saturated? Well, I wrote this SSS. It's a little mnemonic device. It helps you remember that if you are saturated, you are all single bonds, and you're going to engage in a substitution reaction. Well, how does this help us here? Well, it turns out that if only single bonds can be in a saturated hydrocarbon, we can find the information that we need on table Q. Here we are. My friends, the only type, the only family of hydrocarbons that has all single bonds are the alkanes, which have this formula. My friends, only one of these four formulas corresponds to this. Take a look. If I have 4 carbons, that means 2 times 4 is 8, plus 2 is 10, meaning it's C4H10, which is choice 4. 46. Which volume of this molarity exactly neutralizes this volume of this molarity? My friend, there's only one formula that we can use when we have 2 molarities involved. And I have to stop hitting pause while I'm speaking. I cut myself off, not a great impression. Here's the formula that I was talking about. Now, when I plug all the values in, now press pause. I plug in the molarity of the acid, the molarity of the base, the volume of the base. I solve for VA, and that's going to be choice 250. Question 47, given the formula for an organic compound, the name given to the group in the box, well, we have to know, we have to find what it means, what the name is, what the prefix is for 2 carbons, so we have to take a little trip to table P. Let's go. Here we are at table P. F is 2. So with that piece of information, let's go back to the test. Choice 2, ethyl. Choice 48, what type of matter is represented by the particle diagram? Well, notice we have 2 different elements that are touching, meaning they are chemically combined. And that, by definition, makes you a compound. Notice that all of these molecules are identical to each other, so this is a pure substance, but it's not an element, it is, again, a compound. 49, which substance is an electrolyte? In other words, which substance is an acid, a base, or a salt? Well, my friends, the answer is 4. 4 is a metal plus a nonmetal, which of course is a salt. There are no acids here, which we would look for by comparing to table K. There are no bases here, which we would find by comparing to table L. Question 50, which type of organic reaction produces both water and carbon dioxide? This is kind of a spicy meatball, for this reason that one of them produces only carbon but not water, another one produces water but not carbon dioxide, and only one produces both. The one that produces both is combustion. Recall that if you have 3 in a esterification reaction, you make water but no carbon dioxide. But if you do a fermentation reaction, you make carbon dioxide but no water. Again, somewhat of a spicy meatball. I like this one. And congratulations, we have arrived at the part 2 style questions. Draw a Lewis dot diagram for a chloride ion. You'll be answering these in an answer book, which will jump to and fro, which will, some of them we have to. You'll see what I mean. This one I'll just write the answers here. Draw the electron dot diagram for a chloride ion. Remember, if you're a chloride ion, it's a nonmetal ion. Nonmetal ions always get 2, 4, 6, 8 dots. Remember, that's why they feel so great. Square brackets, and you need to look up the charge. Oh, they were nice. They actually gave it to you. Don't forget to put the -1 there. Base your answers to 52 and 53 on the information below and your knowledge of chemistry. Always read these passages, my friend. It has often information that's indispensable to answering the question. Now, number 52, you just have to jump to your answer booklet. You're going to balance the equation. So let's go there. 52, oh my goodness, that is mad easy. I think we'd all agree. Notice here, I have two H's there, one H there, so I guess I have to put a 2 there. And that takes care of my chlorine problem. Now I have two chlorines. That's a balanced equation. Doesn't get much easier than that. 53, explain in terms of intermolecular forces why iodine is a solid at STP and chlorine is a gas. Well, my friends, the reason that you're a gas is that you have weak intermolecular forces. Solids are solid because the molecules or atoms or particles are all held together by very, very strong intermolecular forces. So you would simply say there are strong IM forces. My command of English, my friends, I too has stronger intermolecular forces. Again, not a bad one. 54, 55, they give you a list that we're going to have to refer to as we ponder the questions. Identify one chemical property of sodium from this list. Well, the only one that is, from sodium, forms compounds with non-metallic elements in nature. That's one. And the other is forms sodium chloride in the presence of chlorine gas. You can say either one for number 45. Number 54, reading backwards, I must be tired. 55, convert the melting point temperature of sodium to degrees Celsius. Well, it says it melts at 371 K. Go to table T, guys. Bust out your formula. K equals Celsius plus 273. That is 371 minus 273. So that, of course, is 98 degrees Celsius. Questions 56 through 58 are based upon the same passage. 56, explain why H2O floats on H2O solid, floats on H2O liquid. Well, the answer is right here. It's simple reading comprehension, making ice less dense than liquid water. So it has to be that one. Number 57, state the type of intermolecular forces responsible for the unusual boiling point. Well, remember, my friends, what do we say? We say high on the phone. This is hydrogen bonding, my friends. Hydrogen bonding is responsible for water's unusual properties. Hydrogen bonding. Question 58, determine the total amount of heat in joules required to completely vaporize a 50-gram sample of H2O at its boiling point. Well, we don't need the passage anymore. This is vaporization, so it's going to be Q equals M times HV. If we look up HV for Wawa, water, on our reference table, we get 2260 joules per gram. It's on the front of your reference table. And it's a 50-gram sample. So when we do the math, we get 113,000 joules. Oh, and it occurs to me I didn't explain, high on the phone means that HF will have hydrogen bonding, H2O will have hydrogen bonding, and NH3 will have hydrogen bonding as well. Only 3 molecules that have the extreme polar-polar interactions called hydrogen bonding. Question 59, show a numerical setup for calculating the number of moles of SNO2. And they're nice enough in the passage to give us the gram formula mass. So let's plug in 3 and plug in 151 grams per mole. Of course, we're plugging those values into the mole formula, which you're going to find on table T. Here's your answer, 3 divided by 151 grams per mole. Number 60 is a moles to moles question. I'm given the number of moles of H2. I want to find the number of moles of SN. I have to use the recipe up here to determine this question. I know there's 1 tin for every 2 moles of H2. So I place X underneath 1. I make that the denominator. And 4 moles of H2 underneath the 2. And find 2x equals 4, x equals 2 moles. My friends, that ends part 3. See you in part 4.